they've opted for this 3D first experience, as we call it, where you enter a product detail page and you get presented with a 3D viewer immediately. And then you can opt to look at the images, but spoiler alert, they are of course rendered from the 3D model as well. So the entire concept of 3D first is both in an experience dimension, but also from the production side. If you're going to produce 2D content, it's more cost efficient to do it from a 3D model. We actually had brands contacting us about buying the scanner, and I would heavily advise against it. Building this type of scanner is really not that difficult, and you can do it with lower end gear and still get good results. But collecting that data that's part one of the problem, and then there's a bunch of other problems you need to address. So right now we're talking about the problem from the beginning. It starts with scanning, but what you actually need to do is start at the other end. What are we going to deliver? And then work our way backwards. Then what do we need? How does the process need to be built so that we can deliver those specifications? And I mean, that's our approach with the entire pipeline is, first of all, we need to try to automate everything. We've automated this machine so we can just press a button to scan a shoe. But everything we can't automate, we need to standardize. So we know that if we're going to produce 1,000 shoes, we know how to shoot them to reduce these types of problems that cost a lot of time and money to address in post. So we want to address them when we're scanning them. So there's a lot of learnings to be done there. Like what is your balance between time and quality? And if you save time in scanning, that might cost you time later. So there's a balance in all of these steps. And we've built a pipeline that makes sure that we keep color consistency from the original product to the final 3D model. And then we proudly render it and show it to the clients. And they say, that looks nothing like our images online. What have you done? Because it's quite common practice to outsource the retouch of your product photography to these mass production retouch houses that don't really care about your colors. They will ramp up saturation and they will shift colors around that you barely recognize the product. It can look nice, but it doesn't look like the product. So we actually made diagrams for the client where it's like, this is our white balanced studio photo, this is the 3D model, and this is what's live on your e-com. What do you want us to do here? Because there's a discrepancy there that we don't really want to address, because that's not what the product looks like. We want, of course, to make our clients happy, but we're also saying we believe this technology can reduce your returns, but then you need to show your clients what the product actually looks like. In my team, I think maybe 5% of them come from a 3D background. Then obviously we use a team of 3D artists to do the photogrammetry cleanup, but we're trying to make sure that the 3D artists focus on the specific task where we need them. We don't need 3D artists to scan the products. You don't need to be good at 3D to do that. You also don't need to be a good photographer. So part of being able to scale this is like, does our pipeline rely on having hundreds of highly trained artists on hand? Then it's not scalable. Where we should look to apply AI is more of looking at the different processes in the pipeline and figuring out where does it make sense to remove manual labor. We can have a higher output with the same amount of people, and then we need to look at what is this person doing? Is there another task that we can reduce by training an AI model and getting it down to 20% of what it usually takes? Then we save a lot of money there. So it's about optimizing, and I think it's at this point I would say it would be quite naive to think that we could completely replace what our amazing 3D artists are doing. They're really valuable, and I think they will continue to be valuable.
Hello, Joachim.
Hi,
Welcome to Behind the Scenes. How are you doing?
I'm doing great. Thank you for the invitation to be here.
Now, it's all my pleasure. I am very much looking forward to speaking about 3D today, more specifically about how to go from physical samples to a nice looking 3D version of that. And I understand you as the 3D production manager at the Fibble, right? have figured out how to do it in a very nice way, in a very scalable way. So I am very curious about how you've actually managed, what kind of challenges that you faced. I don't know if there's anything to that introduction that you would like to add about yourself and people, maybe.
No, well, I think Fibble as a company, we set out to sort of address the huge return problems with the e-commerce sector, and we think that this increase in the product experience is what's going to alleviate that problem, and part of that obviously is the scalable 3D production pipeline that we've built.
Exactly. And we won't speak that much about the business of it all. I think here we will focus much more on the technical aspects of the challenges that you have to address, and I think that's also much closer to your the competency, so to say. But just to set the scene for the listeners and audience, I would like to bring in maybe one of the customer websites that use your technology, because I think it kind of renders the final result very, very nicely. So this is Loki, right? And if I'm not mistaken, it's also quite a new brand that has been getting quite some attention, uh, but by some celebrities being part of the launching of it. Is that correct?
Exactly. I mean, they've been around for a few years, but they've recently taken off and have some really high-profile collaborations, and yeah, really exploding on the market. And they've opted for this 3D first experience, as we call it, where you enter a product detail page and you get presented with a 3D viewer immediately, and then you can opt to look at the images. But spoiler alert, they are of course rendered from the 3D model as well. So the
Mhm.
entire concept of 3D first is both in an experience dimension, but also from the production side. If you're
Yeah.
going to produce 2D content, it's
Yeah.
more cost efficient to do it from a 3D model.
Got it. All right. And as we can see here, I mean, it looks it's a very cool experience where you can zoom around, rotate, and really see the details of it. I mean, you can even literally see through the holes here. Um, so you of course get like a very personalized experience depending on what you care about, I guess, right? From a product.
And
Uh,
speaking of personalized experience, you also have the virtual try-on feature, which a lot of customers appreciate, where you can actually look at the product on your own feet through
mhm.
your mobile camera.
Correct, correct, and also AR to basically see it being laid out in the room and maybe compared to your other shoes next to it. But
Exactly, and that's a good feature for bags as well, so you can really assess the size of a product that you're purchasing.
mhm, cool. No, but it really looks amazing. So you can pan around, rotate around, zoom in and out, and so on. But this thing is built by scanning the physical product, correct?
Yeah, exactly. We're using photogrammetry as sort of the foundation of our production pipeline. So everything starts with a good scan. The better the scan we can produce in the front of the pipeline, the easier and more efficient the rest of the pipeline will be. Yeah.
Cool. And I guess that's kind of where I want to start the journey with like what kind of equipment would be needed, because I have seen quite some examples already where people just with an iPhone walk around a bag or shoe or any product and can kind of get a 3D scan out of it. But you shared this image with me, and it's like a half circle, like a half moon,
Yeah, we call it the arc actually,
the
based on
arch. Yeah.
the shape of it. This photo is actually from a trade show in Milano, MICAM, where we went down there to prove our scalable production pipelines. We produced 113 shoes, I believe it was, right there on the floor of the trade show, and then sent out links to all of the visitors that were kind enough to let us borrow their shoes. So a live demo of the scalability of this process.
And that's cool. And I mean, you have to tell me more about this concept, because this one literally seems to be super advanced with multiple cameras, one, two, three, four, five, six, seven, scanning this
Yes.
thing. And I guess the shoe in the middle is kind of rotating, so you kind of scan it from all different angles.
Yeah.
And it just if we can start on one end and go through like the whole process of from here to the final result that we just saw.
Yeah,
What?
I'll walk you through it a bit. Like you mentioned, you can scan with your smartphone, and that's true with photogrammetry.
Mhm.
It's it's in the name, photo. You use several images to sort of uh, align a dense point cloud, so you can build a 3D model out of that, and you can do that with any kind of photo. But
Mhm.
obviously, just like with, I usually compare it to the movie industry. You can shoot a movie on your iPhone, but you probably won't create a Hollywood experience that way. You still need a professional camera. And it's similar here. I mean, we use high-end DSLR cameras from Sony. This contraption that we built here is mostly for the efficiency of it. You need a turntable, you need a multi-camera setup, so you can scan the products quicker. So that's part of the industrialized aspect of it.
Yeah.
But then, of course, scanning is just like the first part of the pipeline. Photogrammetry has a lot of benefits, and it's a really powerful technology. But there are
Mhm.
also, of course, some drawbacks and things that it can't handle.
Mhm.
And rather than disregard the entire technology, it's more of how do we apply that where it makes sense, and how do we plan around the shortcomings of photogrammetry from the
Mhm.
start, so we know what we're putting into the pipeline, what happens after photogrammetry, and what are we going to deliver to the clients.
Got it. I mean, obviously, this seems to be much more of a costly setup than taking your phone and trying to scan it. But I also assume that it's a much more reliable way of making sure that the products are getting the same quality compared to someone manually trying to move around a product. Can you talk anything about from the cost perspective, like what does it cost to get one of these units? I mean, not exact cost, but how feasible is it? And can I, as a brand, just invest in one of these and press a button and get the 3D file rendered at the end?
We actually had brands contacting us about buying the scanner,
Hmm.
and I would heavily advise against it. Building this type of scanner is really not that difficult, and you can do it with lower end gear and still get a good result. But collecting that data is that's part one of the problem, and then there's a bunch of other problems you need to address. So right now we're talking about the problem from the beginning. It starts with scanning, but
Hmm.
what you actually need to do is start at the other end. What are we going to deliver? We know that we want to deliver a virtual try-on experience, the 3D first viewer on the product detail page. We also want to be able to render high-end product images and videos. So
Hmm.
then from that, we can sort of build a specification of what do we need the 3D model to do,
Hmm.
and then work our way backwards. Then what do we need? How does the process need to be built so that we
Yeah,
can deliver those specifications? So
got it.
yeah, it's everything from when you have the material. How do you build a 3D model? What's your poly count? What are the resolutions of the textures? And all of this plays into how you're going to process it and work
Yeah,
with the data that you collect.
lighting, I guess, as well.
Yeah, I mean, for photogrammetry, you ideally want to light it really flat and boring because you want that raw, diffuse color, and then you want to light it afterwards. So you might
Okay.
even have to apply some type of delighting techniques when you got your model, so that it
Mm,
doesn't have any burnt-in highlights or shadows.
got it. All right, but let's assume that it is for multi-channel purposes, so virtual try-ons, the augmented reality, the PDP, obviously, um, and then having those requirements. Now, putting the shoe on top of this plateau here. What do? Do you press a button and then stuff turns around 360, or like what's
Basically,
actually
yeah.
happening?
We put a product in front of the scanner and we push a button, and then it rotates and the cameras go off in sequence. So we capture, for this shoe you see in the picture, probably around 370 photos.
Okay,
Um,
so it's almost like one picture per degree.
Not quite, because we have this. You said 7 cameras. We use 8 currently. But yeah, you just need to make sure you have good coverage.
Mhm.
Things to look out for is if you have fewer images, you can do that. It will probably process faster and scan faster. But will that have implications on your quality? For instance, will you get really aggressive burnt in highlights because of that you have two wide angles between the images?
Okay, so if you have two wide angles, you'll get burnt in angles, and what does that actually mean and what look like? Is it stretching something or?
No, so if you would imagine a high gloss black leather men's shoe,
Hmm.
you have really clear, sharp highlights from the lights.
Yes.
And if you take a lot of images of that product, you can get those highlights burnt in with a smooth gradient that is easy to remove in post. But if you
Okay,
have large degrees between the shots, you get sort of zebra angles,
hmm,
zebra highlights, sorry, on the shoe.
got it.
That's much more difficult to address. So that's a sort of quality efficiency balance that you need to strike and really learn
Mhm.
from. And I mean, that's our approach with the entire pipeline. Is first of all, we need to try to automate everything. We've automated this machine so we can just press a button to scan a shoe.
Hmm.
But everything we can't automate, we need to standardize. So we know that if we're going to produce 1,000 shoes, we know how to shoot them to reduce these types of problems that
Yeah.
cost a lot of time and money to address in post. So we want
Hmm.
to address them when we're scanning them. So there's a lot of learnings to be done there. Like what is your balance between time and quality? And if you
Okay.
save time in scanning, that might cost you time later. So there's a balance in all of these steps.
Can you give some concrete examples? But before you give those concrete examples, I'm also very curious about the under part of the shoe. How do you, as we saw in the 3D rendering, you actually see the all around the shoe, but when you scan it, you cannot obviously scan the underneath. So do you have to make two scans of the shoe and then stitch it together somehow?
We've seen a lot of other actors in this field do that. You actually scan the shoe and flip it over, so you have two scans that you then tie together.
Mhm.
That's really inefficient. So we've opted for another solution, which I would be happy to tell you if you sign an NDA.
Okay, so you have figured. I mean, maybe you can talk to the challenges of addressing or solving that challenge. So obviously you cannot have something underneath the shoe, right? So it has to be free floating to some extent. Or what are the challenges that you have to solve?
I mean, there's a lot of challenges actually going up before the scanning, and just to give you another example for other product types, you have for instance backpacks.
Hmm.
You have a lot of straps that are just dangling in the air, and stuff can't move around during the scanning. Everything needs to be fixed,
Hmm.
almost frozen in time. You could build a 360-degree spherical type of rig. um, Takes up a lot of space, of course, but it's also feasible. But there's a lot of yeah, tricks that you need to learn of how
Hmm.
to address that. Like, how do you fix these free flowing straps of a bag, for example? It's going to
Yeah.
rotate. How do you fix that so it doesn't move around? Because then your scan is ruined. How do you
Okay.
deal with t-shirts that's hanging off of a mannequin?
Hmm.
They're also flowing in the wind, so to speak. But
Yeah.
uh, yeah, there's a lot of. We have a little workshop where we have a lot of dual-sided duct tape, sewing nails, and all kinds of things to make sure that if we spend a little bit more extra effort to get a really good scan, we
Yeah.
know that saves us the effort in post having to fix that with a 3D artist.
Got it. Okay. So basically some kind of you don't want to tell me the secret, but I'll go to guess here. So some kind of transparent glass it could be put on, right? The shoe. It works for the shoe, maybe, You said sphere for other type of objects. For bags, you want the volume, so you have to fixture the wires and things like that on the bag. Um, how about how about how do you solve the problem of clothing? T-shirts you mentioned on a mannequin, but they can be loose fit. So when you rotate that around, then I guess things can move around, right? How do you
So
deal with that challenge?
that's also part of starting in the other end of the equation. Like, what are you going to deliver? And
Mhm.
we recently had a workshop with a client that sells a lot of dress shirts, um, because we first need to define, like, if you're having a 3D experience on your product detail page, do you need the fabric to actually be simulated? That can pose a lot of technical challenges as well. Like, you maybe don't have the GPU power on a smartphone to do that, or if you want to do that, that limits your poly count for the 3D model. So that's what you need to define up front.
Okay, you,
Currently,
you basically mean that if you want the fabric to wiggle around a little bit as you move the 3D model, is that what you mean? So it's not stiff when you move it around?
exactly in the end consumer's experience, if you want that type of experience,
Hmm.
we need to know that up front so we can build a pipeline around that.
Okay.
So what we're doing at Fibble really is, we're not talking about, oh, how do we do 3D great. That's part of what we do, but what we really do is we are building the processes, the pipeline, um,
Hmm.
for new categories. For instance, just because we can scan 1,000 shoes doesn't mean we can do 1,000 dress shirts,
Yeah,
because we need to define what does it mean to create this product in 3D. What are the requirements? Um,
got it.
does it need to be simulated in a video? That's another thing than being simulated on a product detail page.
Hmm.
So it's about
Yes.
defining those deliverables up front so that we then can build a pipeline, because it will look different. We have three different pipelines for different types of shoes, because we can't produce them in the same way. They have different challenges. So it's really about, how do we create the processes to be able to do this cost efficiently.
Hmm. All right. I mean, let's dig deep into those processes and what might be um, the different paths that break up. You said three for shoes. I mean, considering that I have no idea about those pipelines, what is the first step of the pipeline?
First step, as we talked about, is the photogrammetry,
Hmm.
acquisition of the data sets.
Hmm.
Um, then you usually need to sort of process that data in a software like Agisoft Metashape, or you have Reality Capture. There are some free options out there as well. But I mean, the important part for our company is about automating it. So after the scan is completed, we actually don't do anything other than we pack down the products, and then after X amount of minutes, we can look at the raw 3D model in our software, because we've automated all of the pre-processing of the data set, the alignment, the meshing and texturing of the object, because we have already defined what we want out of this product. We already
Okay.
know that this is a shoe and which pipeline is going into. So it's going to be decimated to a certain amount of polygons, and it's going to be processed in a way so that we get as good data as possible, to our
Yeah.
3D cleanup team.
Uh, I mean, anything that you could share about the details about the dissemination, how many polygons, and what's the reasoning behind those things. If you could educate me a little bit on that, that would be very interesting. Um, it also means that you have to do all of these processes um, with different type of products on a large scale, right? Because it's not a matter of sending you one or two products. Literally, the whole collection for the summer collection might change, and it might be like 1,000, 2,000 color variants, which has to be photographed or rendered into 3D and then made available on the web shop. So, also from a scalability point of view, how do you manage that? Um, i I mean, how does the process? How are you? How I guess the question is, how have you built the process in a way where you can manage so large amount of new products every collection, and there might be like 4 or 5 collections a year?
Um, Great question. I mean, it's a lot of learning by failing, as
Hmm.
always. Um, we can look at what we want to deliver and build the pipelines backwards, but then we need to be really attentive to, okay, we're constantly having to spend a lot of time fixing a certain problem with a certain type of shoe.
Hmm.
So then we need to ask ourselves, okay, have we missed something? This might be a new, for us, a new category of products to produce. If it's that big a scale of problem, then we need to accommodate for that by
Hmm.
creating a different pipeline so
Can,
that.
can, can you give example, Joachim, about such, one or two of those problems where you had to create a pipeline for, just to make it a little bit more concrete?
So, for instance, sneakers are really easy to scan. There's a lot of structure in the fabric, which is great for photogrammetry.
Hmm.
Uh, Easy peasy products to produce.
Hmm.
But then suddenly you get sneakers that some of them have a sort of a transparent see-through heel
Hmm.
with some suspension in there. And like I mentioned in the beginning, like photogrammetry is a great tool, but it also has some drawbacks. It doesn't deal very well with reflective objects and transparent objects.
Hmm.
So then we need to sit down and have a little think about that. Like, how are we going to address these areas of the shoe that we know won't resolve well in photogrammetry, so that we plan for that ahead of time? What does that mean for how we're delivering the products? We need an area to be see through. We know we can't just paint an opacity map, because then you're seeing inside of the 3D model, and that's not how it works. We
Hmm.
don't want to sculpt the entire inside of that heel, because we don't have a lot of time to put on it. Then it's not
Yeah.
cost efficient.
Hmm.
So it's about really thinking about these edge cases, or I mean, in this case, it isn't an edge case. We realize there's a lot of these shoes, so we need to come up with a solid way of, when we see that shoe, we know exactly how to process it and how to deal with that.
Okay. Is that something that I guess there is a person that takes the product, puts on the table, right, to be photographed? Is
Yeah.
that person then making that decision about this is a shoe with transparent details, thus do this uh, process and flow?
Not necessarily the same person that's doing the scanning. I mean, when we receive a project, we first define it. We have a pre-production step where we sit down and sort of, we need to log everything. When you have thousands of products flying through, you need to be able to identify where is every client's product in the pipeline.
Hmm.
So that's also something that I would advocate for. You need great project management tools where you can sort of track these things. And that's where we define, like, these are the 1,000 products that we're shooting, and 300 is going into that pipeline, 300 is going into that pipeline. We know exactly how they're going to be produced. It's predictable, cost efficient. We can estimate a deadline for the project, like when will it be done, because we've done it before.
Hmm.
So I mean, you can create, and you can scan almost anything. You can produce anything in 3D if you have unlimited time. But if you're
Hmm.
going to do thousands of the same product, you need, like a factory, you need the right sort of conveyor belt factory machine
Yeah.
for that specific task, and it will be different for different product categories.
Hmm. Yeah, exactly. What's the output rate or throughput rate of one of these machine slash processes? So how many can you scan and get 3D renderings per, I don't know, hour?
So I haven't calculated by hour. We estimate that one person in an 8-hour shift can output between 50 and 60 shoes, when we look at shoes, which is our primary product category,
Hmm.
for scanning. And then obviously we have a computer farm that processes everything in parallel, so that we can keep a good output from the photogrammetry part before it gets sent out. So I think, I mean, from the first scan to finished renders for a shoe is probably. Oh, sorry, I did a thumbs up there. Um, Best case scenario is about 2 hours.
Okay.
but then obviously it's lead times. So we have several of products in the pipeline at the same time.
Got
So
it.
we haven't really reached our capacity for our production team yet. So we're hoping for the sales team to sort of put some pressure on us.
And that's good. All right. Okay. Tell me more about the back to the process again. So you mentioned these translucent, transparent parts of the shoes. Is there any other challenges that you faced that you were not aware of initially when setting up the production line?
I mean, I think I was quite aware of the challenges. Before I got approached by the founders of Fable to take on this challenge, I already had sort of the blueprint for this type of pipeline in the back of my head. I got inspired by there's a guy named Alex Alvarez. He's the president of Nomon School, I think, in LA. If he still is that, I don't know. He put out a big like seminar about photogrammetry workflows and how he built this and automated it. And I looked at that, was impressed, and got into photogrammetry. But I was thinking like, there's another way you can do this. He's not seeing the full picture. Um,
What was it
so
that he was missing?
I think a lot of people are very limiting themselves by the rules of what we think of 3D. Like if you're an experienced 3D artist, you are very well aware of what a good topology looks like and what's a sensible poly count for different types of applications for the 3D model and what kind of materials you need to do. And if you start looking at it like that, like from the bottom up, how do we build the most high-end, latest technology 3D model, and then try to scale that? I think that's the wrong way to approach it. I think we need to look at it sort of, how do we break these rules so we can do it quicker? Like what it's not a matter of what you do, it's what do we choose not to do, because we're not, each of these models aren't $100,000 gonna be shown on Manhattan.
Exactly.
It's like, what's the threshold for good on an e-commerce product detail page? This is mass production of 3D models. You can go to a tailor and get an item made for you bespoke, and that's going to be expensive. But if you buy something off the rack that's factory produced, you expect to pay a different price for that. And what we're trying to do is democratize 3D so that it's available to everyone, and we want to remove that barrier to entry. So this is a mass-produced 3D 3D model, and we need to look at it that way. Like, what do we choose not to do compared to a traditional 3D pipeline to be able to scale it?
Can you give some examples? Because in my head, it sounds like you maybe have less poly counts, or there's some other aspects. But what is it concrete that you can omit and limit?
Poly count is a great example, because I would say the complete opposite. If you want a lower poly count, you need to make sure that they are where it counts. And that might take a 3D artist a lot of manual labor to make sure that it is optimized. If we
Can we also maybe explain poly count so that it's more concrete when you say where it counts? Yeah, just in a pedagogical way.
So, for instance, do we assume everyone knows what a polygon is? We don't need to describe.
I guess it's like some kind of triangular shape.
Yeah.
That creates a mesh.
Yeah, the shape of a 3D model, the geometry of it is built out of polygons. Sort of, you build a picture out of 2D pixels, but you have the shape of an object is made up of polygons, triangles in space. So if you have a ball in 3D, it's not round. It's a lot of tiny flat surfaces that give the perception of a round surface. But everything's built out of triangles in our world, and you can talk about it like with pixels. If you have lower resolution, you have lower quality, or because you might be able to perceive those pixels if they're if you have a low resolution enough. And likewise with a lower resolution 3D model, you might be able to see those triangles, like the edges of the triangles. You could make the argument that a pyramid is a really low resolution ball.
Yeah.
So if you have a really low, if you need a really low poly count model, you need to make sure that you have polygons in the places where you need the roundest shape.
Okay.
Or the smallest details of shapes. So, for instance, if you use photogrammetry to get a raw model, and then you just decimate that down to 20,000 polygons, it probably won't be very optimized, because photogrammetry isn't good at it. It's good at evenly distributing polygons. There are some algorithms out there to sort of try to optimize poly count to where the curvatures are, but they're not very sophisticated. Usually you would let a 3D artist make those decisions. Where do we need high poly count and where can we reduce it? But that takes time, and
Yeah.
time with a 3D artist costs a lot of money. So that's why I would argue the opposite. Like, if you're able to keep the file size down, you have enough GPU power to render, then it's more cost efficient in the production part to have a higher poly count,
Okay.
if that makes sense.
Almost. So what's the relationship between compute? I mean, you said, what was the first thing? You said the first thing was, and that's the
Yeah,
compute power.
since we, I mean, for our product, we want people to be able to shop while on their phone, like while they're out and about. So they will be downloading these 3D models from the e-commerce via 4G network or something. So we need
Okay,
to
so
keep
the
the
file
file size.
size.
Yeah.
Yeah. Okay, but to me, file size, keeping it down, basically, in my head, meant keeping the poly count low. But you're saying that's not necessarily the case.
That is the case, and that's my point. Like, if as long as you got enough room in your megabyte budget
Yeah.
to have more polygons, then that will save you time rather than having a
Got it.
3D artist optimize it.
Got it. Got it. Yeah, makes sense. All right. Okay, and this is something that I mean, the production line that you've set up, you have been able to figure out like an optimized way without an artist to tell the system where it needs the most or less polygons. Is that correct?
I won't go into specifics of how we solved it,
Okay.
but basically, yeah, you like I said earlier as well, you need to start at the end. Like, what are we going to deliver? For our models, we need them both on the product detail page and also high quality video. So what's the intersection between file size, rendering performance, and a high resolution model? Like, that would be individual. I mean, I don't think it would be relevant to even talk about numbers, because it will be different depending on how you're going to use these models and what you're using them for, and how are you compressing them and how are you rendering them. There are a lot of things that you need to, if you're building this type of pipeline, you need to first figure out what is the end result.
Yeah.
Because if you start with we're going to produce 3D models, and you start producing them, then you're going to run into all these questions and have to solve them after the fact, and that's expensive.
Yeah.
So figure out what's the deliverable, what's the purpose.
Okay. So
And
it's not really the same way where when you play around with images, for example, we usually say just send us the most high resolution image, and we'll just scale it down to different MIP maps, and then use it the correct size, so to say, depending on where in the application or in the UI it makes most sense. So basically, you can start with just saying like, just scan it with as much polygons as possible, and then we'll, depending on the application, we'll customize it. But you're saying that is not feasible or easy to do?
It can be. It can be, for sure. There are a lot of really competent softwares out there that can decimate and create new UV maps on the fly, depending on your needs. We actually use one of the third-party solutions out there, Rapid Compact. We have a great collaboration with them. We use them for some things, but of course, the more precise you can be, the easier and quicker you're going to produce, rather than solving the problems further down the line. You want to make sure if you can have a complete clean input to the output, that's optimal, right? All of the operations you need to do in between is a cost and a time associated with it.
Yeah. Cool. Any other in the pipeline, those things that most people do manually that you have addressed? I mean, just what are those things more?
Oh, rendering content, for instance, is one thing that's really. I mean, we are moving towards a more three-dimensional experience online, but the reality is we still use a lot of 2D content, images and videos for marketing, social media, etc. So I think that's also one place where we are able to save a lot of time. That we've built a rendering pipeline that's, and this, I keep coming back to it, but it's about planning, right? So we need to set up, if we need to render this, then the model needs to be set up in a certain way that our scripts can pick it up. We can create the shaders that we want. We can create the lighting that we want. Lighting.
Sorry. What is shaders?
So shader is, you have different type of rendering techniques, right? A real-time renderer or an offline renderer might have different resources, different way to calculate light and shadows and stuff like that. So a shader is basically how do this renderer interpret the material of the object.
Okay.
So that's where you would input your if you have PBR shaders, you input your diffuse, your roughness map, your metalness texture. Maybe you have a normal map in there. So that's very different from if you have an offline render for videos and images. That will look very different from your probably GLB or GLTF file that you have on your product detail page. So planning ahead, we know that this model is going to be split up and go both these directions, and how do we accommodate for that in the step before, so that we don't need to do a lot of manual work. And it's not only decimating polygons, it's also about resolution count. We want high resolution, for the textures. We want a high resolution in the images, but we can't use that on the e-commerce website because it's too heavy. Again, you need to download it, you need to render on your smartphone. So it's all about planning ahead and making sure the input into those processes gets the right data.
I mean, is okay. Is there anything that you can share? Because I'm not curious. How do you make that decision at that point in time? If it's not someone manually doing that, or is it when you say it needs to planning? Is that what is being decided with the project management when you get the products and someone looks at them? Is that the point when you define when what
No,
goes?
it's rather like per product category. If we're doing shoes, we know how much, what's our megabyte budget. You don't want too heavy file. You want maybe 3 or 4 megabytes to be able to download it quickly.
Yes.
So how much details can we cram into 3 or 4 megabytes? What's our resolution of the textures, and how much polygons can we have? I keep doing this thumbs up by mistake. I'm sorry.
Okay.
So what's the texture resolution and what's the poly count to be able to fit into 3 megabytes? But that quality will be insufficient for the rendering. So then we know that, okay, from the photogrammetry, we need more resolution and more poly count than we want for our
the web
online experience.
Exactly, because when rendering, we want to have as it also takes much longer time to render one image, right? Um,
Yeah,
mhm,
exactly. So that's where we want a high resolution, because it's allowed to take more time,
mhm,
rather than a real-time render online. So just knowing that we want one specification here and one specification there, how do we optimize for that?
yes,
Is there an intersection where we can compress polygons for the online experience and keep the same count for the renders? Then
yeah,
we've saved time, because then we don't need two meshes.
exactly. Is that the
Can
case?
we? Can we? That is the case.
Yeah, that's
For
nice.
for the textures, we know that we want one resolution online and one for the renders. So how
Mhm,
do we plan for that? We need to build our scripts and automated pipelines so that we get all of that data, everything that we need. We want to get it before we need it, because we don't
mhm,
want to stand there and create it after the fact, if
got
that
it.
makes sense.
Yeah, of course. Okay, I mean that definitely makes it a bit more clear for me. Can we also talk about how you deal with lighting? You said that you want as dim light environment as possible. Maybe
I
not
would say
dim. What was the word?
very flat lighting.
So um, flat lighting. What does that mean? Is it the same light all over the place?
Yeah, big soft boxes, no harsh shadows, no harsh highlights.
Hmm.
It least needs to look kind of flat and boring.
Okay, and that is because once it's scanned, you can in the 3D rendering or 3D viewer later on
Exactly.
apply the shadows and the lighting as you want. Is that correct?
Exactly. And that's where, like, some clients have different needs. For instance, if you're looking at a sport retailer that sells sneakers, they usually have sort of also kind of flat lighting in their images. It's just, it needs to look sporty.
Hmm.
But a more high-end client with nice leather shoes, they usually opt for a more dramatic look. So they want
Hmm.
a harsher shadow and a highlight on the front of the shoe. And to be able to do that lighting in 3D, you need to have like as flat as possible lighting when you scan the products,
Yes.
and also do some delighting after the scanning.
Hmm. Okay, makes sense. And in regards to the colors and making sure that they are as close to the you're smiling, close to the physical sample, so to say, how, because I know that is a challenge no matter what, but have you figured out any cool ways of addressing that?
We have figured out very cool ways of doing that, and it's usually, unfortunately, not very appreciated. So
Why?
I'm going to, if I'm allowed, I want to tell you a little story that seems to repeat
Please.
itself quite often.
Yes.
We have we color calibrate our machines every morning to make sure that our lighting hasn't gotten a shift or a tint because of old age. They do that sometimes. So
Hmm.
everything's always white balanced and color calibrated. And we've built a pipeline that makes sure that we keep color consistency from the original product to the final 3D model. And then we proudly render it and show it to the client. And they say, that looks nothing like our images online. What have you done?
Yes.
Because it's quite common practice to outsource your the retouch of your product photography
Hmm.
goes out to these mass production retouch houses that don't really care about your colors.
Yes.
They will ramp up saturation, and they will shift colors around that you barely recognize the product. It can look nice, but it doesn't
Mm.
look like the product, and
Hmm.
that's a
It
really
pops,
common.
but it's not realistic.
Yeah, exactly.
But that's interesting. Uh, have you then taken countermeasures to make it look more non-realistic, or do you usually convince the customers that you know this is the best way?
There are multiple dimensions to this. We have built features where we can do some post processing in the 3D viewer
Hmm.
to try to match the client's expectations. We
Hmm.
can set individual lighting and contrast and saturation per product for the clients to try and match their product photography.
Mhm.
But what we don't want to do is really shift around with the colors. We had, for instance, one client where the retouch agency they used, it's quick. They're getting paid pennies per image.
Mhm.
They just click white balance and click on the sole because
Mhm.
the sole is usually white, and then they get the colors. Except this client had a lot of cream colored soles.
Mhm.
If you white balance to a cream color, you shift all of the colors in the shoe.
Yeah, yeah, yeah.
So
Like,
we actually made diagrams for the client where it's like, this is our white balanced studio photo, this is the 3D model, and this is what's live on your ecom.
mhm.
What do you want us to do here? Because there's a discrepancy there that we don't really
Yeah,
want to address, because that's not what the product looks like. We
exactly.
we want, of course, to make our clients happy, but we're also saying we believe this technology can reduce your returns.
Yeah.
But then you need to show your clients what the product actually looks like.
And what do they say?
We usually when we describe the problem,
Yeah.
we usually get through.
Okay. That's good. That's comforting.
Yeah.
Um, cool. Another challenge I know is usually like this size and fittings. So you might have the shoe in multiple sizes. Um, Maybe it does not matter too much. Like you just photograph one of the sizes. Doesn't matter which one. And then maybe you can also talk to other products where it actually does matter and where the product can almost change in fitting and shape for dresses or certain type of pants and sweatshirts and so on. So how do you compensate for that? Is there any way to compensate for that?
This is a really big issue for the entire industry. It's a difficult problem, and I haven't seen anyone that's come up with a really solid solution. For us, we ended up with going with, let's scan the most common sizes for men's and women's shoes.
Hmm.
So we ask for that up front when we talk to the client. Hey, we would prefer to get everything in this size.
Hmm.
Um, Sometimes we get other sizes and feel like that's fine. The problem, of course, is if you have a virtual try-on experience and you scanned all the shoes in size 46. I don't know what that is in US size, but really big.
Yes.
You can't really scale them uniformly to fit your foot in a virtual try-on application, because they don't. When you go up a size, it doesn't scale uniformly. There's different
Yeah.
proportions to the shoe. So
Okay.
we've tried just going with an average so that we can
Hmm.
give a good virtual try-on experience for all sizes,
Yes.
because this is a problem that I don't think anyone has really solved. You could, of course, scan all of the sizes, but that would
Yes.
really hamper our production output.
Got it. And that it applies then also to clothing and accessories.
Even more so because you have more shapes to take into account.
Hmm.
I mean, a size 9 shoe is always a size 9 shoe, but
Yes.
with slim fit
That makes sense.
shirts and different materials, yeah, it's a big problem for the industry, and
Hmm.
we unfortunately have no good solution for this, and that's not our primary focus either at this moment.
Hmm. Got it. Because when you do scan the most common size of the shoe and then use the AR experience and lay it out in the space, so to say, on the floor table, you will get the shoe in the size in relation to everything else object, right? So you'll get like a 43 centimeters shoe or 43 size shoe will be equally, I mean, taking up equal much space on the table as if you put the real size there, correct?
Exactly. So there's two different applications that can be relevant to talk about here. So our models are to real world scale,
Hmm.
but in the virtual try-on, we scale it to fit the foot
Okay.
that we want to track and superimpose the 3D model on. But when you place it in AR, it is in real world scale. So, like I talked about briefly, if you buy a backpack, you want to know the size of it, and you can trust that the AR model is to scale. Of course, within a margin of error, because both Android and iOS can approximate the size of the AR environment, but within that AR environment, the 3D models are real world scale. Yeah.
Got it. And what type of maximum size, width, or height of a product can you at this point in time scan? Like, could you scan a long coat, for example, a jacket from top to
Yeah,
toe?
I think our machines that we're using currently, we everything garment wise is not a problem. We've run some tests with jackets and pants, and there's, I mean, we can fit that in there. We've done big gym bags like duffel bags and big hiker backpacks. So there's quite a range, but we're not going into product categories like furniture and really
Got it.
cumbersome products yet. We're focusing on the apparel basically.
Mhm. Cool. Because one thing that would be quite nice is we have some wholesale fashion brands that I work with, and many times they want to merchandise stuff together, right? So they want to put a jacket and then the pants and the t-shirt and create an outfit almost. And usually when we just work with the photographs, it's just the same size, and you don't get the size in relation to the other ones, so it's hard to basically tell how much bigger is this jacket compared to this sweatshirt compared to that belt and so on. So I guess that is something, even if you would render, you could possibly then, based on the model that you have, tell as a metadata to this image, this is the size that you can see in this photograph. And that could.
Yeah, I mean, two points to that. One use case we have is with backpacks. We've implemented a feature that you can, even in the 3D viewer online,
Mhm.
toggle on and off to see like the dimensions. You get arrows like across showing this is the height, this is the width. But we also discussed in AR um, if we could assemble an outfit like these pants and this jacket, and then start the AR experience and just place like a virtual mannequin
Exactly.
with that outfit.
Mhm.
It's something we've discussed, but we're not looking into it at this moment. But it would be really interesting application for sure.
Mhm. I mean, at least just to be able to put the products in AR next to each other in the correct dimensions would be
Yeah.
cool enough. We've also tried a little bit with virtual dressing up a model. That seems to be not really there yet in terms of generative AI or other aspects. And I guess in your case, the challenge is also because you don't have the 3D model designed from scratch. It's more of photographed things, so it might be hard to be aware of all the details if you want to place it on someone that has a different posture.
Exactly. Yeah.
By the way, it's also in your case you require a physical object to photograph. What are the pros and cons, maybe, compared to designing the product from start in 3D, in terms of later on making that content available on the website? I mean, quality wise, or I mean, anything that you can talk about.
At this moment, I think the way we're doing it is so cost efficient to produce 3D models.
Mhm,
Of course, there's another aspect of it, like this, like you talked about, designing and then maybe having an end-to-end, like from design phase to actual production to then marketing and e-commerce.
mhm,
There are some brands that we've been talking to that are working on that. Uh, from my perspective, yeah, similar principle would apply. Like if you plan for that entire full picture, then you can probably produce those 3D models in a way
mhm,
to accommodate for it.
mhm,
Generally, if you model something by hand, it's difficult to nail that authenticity.
mhm,
This is one of the real strength about photogrammetry. You can really get a feel for organic materials,
mhm,
textiles and stuff like that. There are fantastic simulations in Clo 3D and Marvelous Designer
mhm,
that can give convincing results. but there's something a bit gritty and real about a photogrammetry scanned
Mhm.
assets in my mind. Of course, I'm biased, but
No, no. I mean,
yeah, that would be a challenge, I think, if you are doing it from design phase and want to use that material all the way to online on your e-commerce.
mhm,
Getting that same realism in
mhm.
the product experience at the end, I think, would be difficult.
Yeah, I actually had in the episode before this one talk with a fashion designer that went to 3D designing and had an interesting discussion. And my understanding is that it's also quite um, eh, like expensive and takes a lot of time to set up that process of designing this stuff. You know, a lot of people need to learn the software and so on, and you need to create like all of these libraries of assets of textures and you know all of these things so that you can really work in an effective way with the suppliers back and forth. So it seems to be doing once you get that up and running, it seems to be doing quite good of a job in optimizing certain aspects of production or design production. But I think one kind of challenge here is that that product will eventually be produced anyway. So if that would be a process where uh, you know you just do it once and then you don't have to think about the physical object, a lot of times time spent saved. But in this case, you do that. It helps you in the design process and so on. But as you said, uh, it might not be as easy at this point in time yet, at least, to get the authentic feeling compared to just photographing the actual product in front of you. Um,
Yeah, I think there's also more dimensions to that. You mentioned it being expensive, and yes, that's you would need 3D trained artists to do that, and then
mhm,
you need to do it at scale.
mhm,
So what we've been doing is, I mean, the pipeline we're building, we're trying to simplify it.
mhm,
So, I mean, in my team, I think maybe 5% of them come from a 3D background. Then obviously we use a team of 3D artists to do the photogrammetry cleanup.
mhm,
But we're trying to make sure that the 3D artists focus on the specific task where we need them.
mhm.
We don't need 3D artists to scan the products. You don't need to
Exactly.
be good at 3D to do that. You also don't need to be a good photographer.
Yeah.
So part of being able to scale this is, can we, like, does our pipeline rely on having hundreds of highly trained artists on hand? Then
Mhm.
it's not scalable.
Yeah.
So
Exactly.
that's what,
Especially for smaller, medium, smaller brands,
yeah,
because you really have to set up a photo studio, align it with, you know, later on if you photograph the products, it has to be in the same
yeah.
scene, so to say, so that you don't see a difference between product to product. Some of them will be physical, some of them 3D. But I'm wondering, maybe for smaller brands, even though they cannot potentially, you know, reduce the need for creating physical samples for their wholesale business, you know, 6 months before it's arrived to the stores, at least for smaller brands, that they could utilize this type of technology to at least in the factory for um, create the 3D models and ship that basically to the showrooms and to the salespeople, uh, and still be able to take advantage of some of the sample decrease, you know, not being have to handle samples to the same extent, and then eventually when technology gets more effective, more cost effective, so to say, then they could also start producing the content, designing the styles in 3D. Do you see that this is a technology that could be applied in a cost-effective manner already when the products have been produced for wholesale and then utilized later on for retail instead of waiting to photograph uh, the final product, um, you know, just before it reaches the stores?
Yeah, I mean, we that obviously is one part of our strategy. The
Mhm,
higher up the chain we can scan the product, the better for the client in the end, right?
mhm,
Um, but that's strategic partnerships that has to be made to do that. I think what you said about smaller brands, I think it's difficult for them to also set up this kind of pipeline that we have on hand, because there are a lot of moving parts.
Hmm.
You still need uh, 3D competence where you want to apply it.
Mm.
You also need to be really process driven about building this type of production facility.
Got it. That's true. Do you think that maybe also a closing topic, to wrap the session? How could AI, machine learning technologies, influence and impact this type of process flow that you have? Maybe you're already using it, but if not, what type of areas do you see it can further make automatic, or improve the quality on?
So yeah, AI is a hot topic. I get asked this quite a lot, and I think AI will be really important and valuable, but not in the way that you would intuitively think about it.
Mhm.
A lot of people have been talking about generative AI, which is a problem when you want to represent an actual physical object
Mhm.
that people can buy and hold in their hands. Because if it hallucinates or invents some part of the product that doesn't exist,
Yeah,
that's
exactly.
not a good experience. You need this specific product in 3D.
Yeah.
So that's somewhere I think AI will not really be applicable. People also talk about NERF and Gaussian splatting a bunch, which is, of course, built on machine learning techniques. Cool technology that I think is not quite mature enough. It's also not a
What
traditional
is that technology? You said Nerf and.
NERF and Gaussian splatting. They are similar in some ways, where you so the data acquisition can look similar to photogrammetry. You
Mhm.
photograph an object from different angles, and then you train an AI model on how to represent that from different angles.
Mhm.
So this is not a traditional 3D model. We have a lot of infrastructure that's built around polygons and textures and and material shaders, like we talked about.
Okay.
And these nerfs and Gaussian splatting exist entirely outside of that realm.
Mhm.
So you would need to forego all of these benefits of the existing infrastructure, the way that people have been working with and like editing and displaying and rendering 3D models for 35 years. You would need
Mhm.
to forego that and just go with this new technology, which is quite limited in its application. So it is interesting.
So you feed in the images from different aspects, and then it figures out on the fly, so to say, how to represent it from different angles.
Yes. How do we interpolate between these camera angles that we do know about?
Okay, cool.
And so it's not a 3D model. It's a volume type of rendering that
Mhm.
only exists like on the GPU as it's being rendered and displayed.
Mhm.
So it is quite limiting in its usage. Um, but I think where we should look to apply AI is more of looking at the different processes in the pipeline and figuring out where does it make sense to remove manual labor
Mhm.
with an AI model. But then we need to be really specific with what it should do.
Okay. Have you seen such examples? I mean, are you guys thinking about any such places
We
in
are
the
thinking
process?
a lot about this and trying to define where. I mean, it's always like that when you have like photogrammetry is one step of the pipeline, but it's a big pipeline with a lot of different processes going on and some in
Mhm.
parallel even, so we can cut down time. And we need to look at where do we think we can reduce the most time and cost at this
Mhm.
moment. Um, 2 years
So,
ago, we switched out our scanners, so we got faster scans. We can shave off another minute per scan, but that's not where we should put our money. Now we should look at other part of the processes, like the 3D cleanup that's still very manual and yeah.
okay, so 3D cleanup in terms of, where it's scanned wrong stuff, or like certain polygons that is not needed. Um, is that something AI can input?
Potentially. That's the beauty of it. We don't know yet.
Okay, okay. All right. I mean, it feels like it's one of these things like uh, it seems so cool, but it yet hasn't really found its applications down to verticalized businesses. So,
Yeah.
so it's,
And I mean, overall, like this entire conversation, I get a lot of people like looking for a one-stop shop solution. Like, oh, we want to do photogrammetry. Oh, it has drawbacks. Let's chuck it in the bin and do something else. And let's look
Mhm,
at Nerf or Gaussian splatting, and that
mhm,
has some limitations. So chuck that in the bin. Can we use AI?
mhm.
That's the wrong approach. You need to figure out what tool to apply and where. So
Okay,
AI could be a really valuable tool, but you need to be really specific on where you apply it and how you do it. Because
okay.
there is no one hammer that can screw in all the screws. That's not how it works.
Yeah, exactly. I agree. So my last question would be looking at your process with the type of way you end up in a 3D model. There's still some manual labor that is going on in that process. I guess that is to some extent your goal to, from a 3D production manager point of view, reduce that, keep the quality or improve it. Do you think that we'll ever succeed with fully automizing it? And if so, how far away are we?
That's a difficult question. I No, I think we can. I think we'll have to have some manual touch points, and I think we also can benefit from that. Um, I think you need to be realistic, especially when you talk about training AI models to replace humans. It's an AI is can be very competent,
Hmm.
but there's a lot of like exaggeration in what it can do. We're more looking at if we can reduce one task by
Hmm.
80% for a person. That's
Yeah.
great. We've saved a lot of time and money. We can have a higher output with the same amount of people, and then we need to look at what is this person doing. Is there another task that we can reduce by
Exactly.
training an AI model and getting it down to 20% of what it usually takes? Then
Yes.
we save a lot of money there. So it's about optimizing, and I think it's at this point I would say it would be quite naive to think that we could completely replace what our amazing 3D artists are doing. They're really valuable, and I think
Hmm.
they will continue to be valuable. I just think we need to use this as another tool
Hmm.
to help them excel at what they do.
Cool. Now that's last comforting words, I guess, for us a 3D artist. And with that, Joachim, I really thank you for all the insights. It has been a good learning for me. I hope you've enjoyed your time as well in the pod.
It's very nice talking to you.
Cool. Take care, and hopefully we'll see you again soon.
Yeah, take care. Thank you.